Excellent. So we have our next guest, enormous international experience in various multinationals. Their experience, the last company he's been following, boasts a great experience in the management of complex sites. So imagine mines, skyscrapers, where you have to computerize, a lot of things, and they come and they must understand immediately what should be done. And there are some very interesting videos. So a round of applause for Doug Brent, our next guest.
Hey Doug, how are you doing? Welcome. Grazie and I'll see you later.
So Marco, I don't speak Italian. You said distinguished, good-looking. I'm just trying to undernd what my introduction.
I just said, unfortunately now it's coming.
Okay. Thank you very much. Thank you so much. Good morning, everyone. I'm going to work my way down to the end of the hall here. I think we're here today to talk future. This is what I think we're here to do today. And I think we imagine a future that has autonomous vehicles, virtual reality, where the world sort of creates the products and brings things to us that we need. And I guess what I want to talk to you about today is I think 1.0, the version 1.0 of that future is actually already here. And I'm going to use as an example my experience, which is in this big industrial world. I say if it gets you dirty, then I'm excited about it. That's an interesting product. And so let's go over some of these things. Internet of Big Things. So we all heard this term, Internet of Things. Some of our other distinguished panelists have been talking about this for decades. Internet of Things is not a new idea. Internet of Big Things is maybe a different way to think about it. Let me ask the audience, this picture in the upper right-hand corner with those monitors, anyone know what that is? Anyone would care to guess what that is? Television, well, that's not exactly right, Marco. So those screens, those three, and actually you can find some with 7, is the inside of a modern farm tractor. So you can sort of see in the background all that green. That's what a modern farm tractor looks like today. I think on the left there's a big long-haul truck, big piece of Caterpillar equipment. I'll talk in a second about that one on the bottom. Each of these things are connected devices. If you look at long-haul trucking in the United States, there's something like 2 million long-haul trucks that are connected to the internet right now today. These kinds of heavy equipment, we'll talk about that a little more, are also widely connected, and farms today are connected. So why is that? Why would they want to be connected? That these devices, pretty much for this Internet of Big Things idea, it's tracking, it's tracing, it's sensing, maybe how much water is being produced, and it's used as a form of individual optimization for that machine. We care to be in a world where we're using less energy, where things are more efficient, more productive, and that's why these machines are connected. If you look in the bottom right, I come from California, this is extremely important to us right now, is water. Water is a key resource for us. These are big 20-meter long watering systems on a farm, and it turns out each nozzle, each place where water is emitted is individually controlled by this Internet of Big Things to ensure you're using just the water you need. The farmer actually gets a water map of their farm and only waters the portions that are dry. So step one, I think, of creating this future that we talk about is connectivity. And with millions of devices around the world, we're not quite ready yet there on the consumer world, but in this industrial world, that really already exists. So I'm going to use the term 3D printing a little different than Greg. Greg is right. I'm stretching things a little bit here. But when I talk about 3D printing, I'm talking about the automated processes that change the world. And I like that picture on the left-hand side with a big Caterpillar dozer saying, I'm a 3D printer too. How is that possibly true? Well, this 3D printer, by the way, I think that's about a 75,000 euro 3D printer, receives instructions wirelessly on how to move dirt, how to create the world around us, and then can automatically execute on that. Now, if you look, probably for many of you it won't be that exciting, but if you look at the top of that blade, you'll see these 2 yellow masts sticking up. What those yellow masts have on that is a positioning system. It's a GPS, GNSS-based positioning system that will give resolution of centimeters or millimeters on the accuracy of exactly where that blade is. So that both the orientation of the blade as well as how high it is off the ground. It can ensure that it's moving the right dirt. So just, again, imagine this. It's getting a model, a 3D model of the ground. It's positioning itself in the world and then moving the dirt to achieve the desired result. To me, 3D printing. Greg, are you okay with that? All right, so we're still okay. There's going to be a quick video clip. It'll move by pretty quickly, but I want you to look at that picture in the upper right-hand side. So, may not be that exciting just to watch in video, but so why is this important? Again, I think we care about saving resources. We care about doing things efficiently. We want nice, smooth roads. Think about a runway at an airplane. You want this to be nice and smooth. Again, this is done completely automatically, and by having an automatic 3D printed road, you can end up saving millions of tons of material because you can hit the design spec, you can hit the local municipal requirements, but you don't have to use anything extra. This one, again, may be a little bit loud looking on the bottom right-hand side. That was not intended. So that musical interlude was not an intended part of the presentation, but maybe it woke everyone up. It woke me up a little bit. But the idea there was that if you look at this long stretch, when a farmer's getting ready to prepare a field for farming, one of the things they have to do is ensure the water will flow correctly. Again, they have a 3D model of the terrain of their farm. They can send the program to that machine who's going to cut the path and ensure that you get a very nice, and you can see this over quite a distance, a well-groomed path so the water flows the right way. Again, minimizing resource, doing this in the most efficient way possible. So step one, we have connected machines. Step two, we can send programs to them to effectively make them 3D printers. The third step is how do we orchestrate mini machines? So much more typical than seeing a single machine or a single person or a single vehicle is we have lots of things all operating together. So if you look at a big farm in North America, you'll see many devices all out there at one time, and it actually can be a pretty scary place to be. You don't want to be in front of any of those vehicles. So the question is not only how do you optimize any one, but how do you orchestrate across those vehicles to ensure you get the right answer? I'm going to show a video. I hope maybe the volume, if there is music on this, could be turned down a little bit so we're not too excited again. But if you look in the upper left-hand corner, that woman who looks quite happy, this is a Volvo idea about orchestrating vehicles. So she takes her hands off the wheel.
It looks like a normal truck with another truck and 3 passenger cars behind it. In fact, this is the first time ever that the Sartre project tests a road train on a normal motorway in everyday traffic conditions.
I think it's really impressive.
So this is, I think, an interesting form of orchestration. We talk about autonomy. No doubt autonomy will come, absolutely no doubt. There's no technology limitation. There's still a lot of hard work to do. This is a different way of orchestrating, which is I can have a human, a smart driver in front of this train of vehicles. That smart driver then becomes the orchestration means. So we can put a little human intelligence, but still get all the benefits. If you're in one of the following cars, you have all the aerodynamic benefits. I can fall asleep. I can take my hands off the wheel. One more example, and again, watch a little bit on the volume. Look in the upper right-hand side. This machine looks very scary. And actually, you don't want to go anywhere near it. This is how sugarcane is harvested. And the farms are gigantic. In Brazil, they have 2,000-kilometer square farms where these vehicles operate 24 hours a day, just like an outside manufacturing facility. And watch how these vehicles work together. So you see, the goal is achieved not by just one cutting, and I've actually been out there on those fields, and again, you don't want to be that close. It's not only the one cutting machine, there has to be a receiving machine for that material as well. They want to work together, and then there's hundreds of these kinds of machines all over a farm. Last example, it's not a movie, so you don't have to protect your ears, but is this picture of all these construction cranes. If you want to get videos of some of the most fantastically destructive YouTube videos you could ever see, just search for construction crane in YouTube. You can look at this work site and say, how do you avoid these cranes hitting each other? Essentially, each of those act as an elevator to bring up material. How would I decide how the material gets stationed so that it's most efficiently ready right now for the manufacturing process? We don't have an answer for that yet, but this is an area, again, where orchestrating all the job site work becomes very important, and it's something people are working on right now. So just to move a little more quickly, clearly the purpose of this orchestration is not just to move things around, but allow people who are doing work to get to more answers that they're interested in instead of just data. So this is the one on the left, where it says Connected Farm, is a farmer's screen. Today, what a farmer looks at is, how do I plant my field? Ultimately, if you look at the left-hand side of this, it's what are the commodity prices right now? Where am I going to make the most money? What would I plant next? What kind of seed is being most productive? In my microclimate of my farm, how would I do that? So more and more, instead of combing through data, let the data tell the farmer what the right answer is. And that's the optimization. So to get this world where things can be made for us automatically, you need to have some way to design that world. And more, this can't just be drawing lines, architects drawing lines or designers drawing lines. And I'm just going to go over one of these examples based on time. And if you look on the right-hand side in the bottom, that's what an open pit mine looks like. These are gigantic. They can be a couple meters across. And it takes people about a month to design an open pit mine. All you need to know to design a mine is you need to know where the gold is, you need to know where the valuable material is, you need to know the rules for how wide the road has to be, how steep a bench has to be, and then tell the computer to design it for you. And we've actually gone through and changed this process of design such that knowing the answer you want, not just the data, tell me where the gold is, will design mines like this in a matter of hours instead of months. Just looking at my clock. I will make a last comment on the left-hand side. If you look up at that picture where it says 3D warehouse, this is a place where 2.5 million 3D models are stored. And think about if you could go to redesign your kitchen, instead of just talking about a new dishwasher or a new oven cooktop, you could pick out from the 3D warehouse exactly the one you wanted with all the information about thermal loading, how much heat is this going to put in your house, exactly how will it connect up with all the other parts in your house, and make this design, part of the smart design to be executed on automatically. So the last one, again, being a little provocative on use of words like this 3D printing, is instrumented reality. We've all heard of virtual reality. So that's basically Oculus Rift or others. I'm wearing something on my eyes that creates a virtual world. Problem would be if I was wearing Oculus Rift right now, I wouldn't feel that comfortable walking up and down this runway. I might trip. So there are these devices that are more focused on augmented reality, or the term Microsoft uses, mixed reality. If you look in this upper left, the little elephant in the hand, this is a company that's not an announced company yet, Magic Leap, but if you look on the web, you'll find a lot of information about Magic Leap. Google and two VCs last year put $500 million into this company to really be delivering a practical version of augmented reality. In the lower left-hand corner, you see a Google Project Tango, and actually the company I work for, Trimble, worked with Google as a partner on commercial applications of this. Now, what's interesting is if you look at that picture, you can sort of get the feeling that that device is mapping the world around it, not just visualizing information on top. And that's what I mean by instrumented reality. For augmented reality to work, I need to be able to map the world around me to put the objects in the right place. I'm going to end with a 1-minute video and it's about Microsoft Hololens and gives you an idea of this. If you haven't seen Hololens, if you're a student, go look at this. But it's a computer, essentially, that you wear on your head that allows you to see the virtual objects in real context.
In the real world.
You get the physical model as a focus point for the team to collaborate around. And you get the hologram with the flexibility, with the ability to run quick iterations.
You'll see how we've brought in the courtyard that you suggested. You see that mouse go off the screen and into holographic space, and you're then interacting with the hologram, with the mouse.
The thing that we can do for architects is really give them much higher confidence around decision making. One way we can do that is we can allow them to literally immerse themselves in the scene that they're building and see street side how the building's going to look.
Visualizing design data in the context of the real environment is a much better way to make sure that the design is implemented correctly on site.
Microsoft HoloLens allows you to collaborate with somebody regardless of distance, like they were there. Hello there.
Hey Igor, where they're trying to put this door, there's a beam behind here.
I'm looking at this beam. We're interacting with it about a problem that we can see and being able to solve that problem with all the data that we need in front of us in real time.
So I'll just finish by saying the very first tweet, or one of the very first that I saw go by on the screen, said the future is here. And I think the version 1.0 is here, and Piaggio Fast Forward will help with version 2. Thank you very much.
Good job, Doug. Good job. Look at this. All right. By the way, before your presentation, we were almost there, on Twitter, these Twitter trends.
Yeah.
After your presentation, we are in Italy, top Twitter trends. So
okay,
just a big applause to all of you because you did it. So good. You gave the final edge.
All right.
Very interesting, very interesting. Also, this I watched a few videos of Magic Clip online.
Yes.
Very interesting. I mean, they create this virtual reality, and you can change things. Okay, let's get some questions from the audience.
Please.
And we try to see how it goes. By the way, did you know that tractor videos online are some of the most watched videos ever?
I thought only by me. I love this tractor stuff. I don't even think I said that in North America today, more than half of all tractors are automatically guided. Humans are not allowed to actually steer these because it's so precise in terms of how it traverses the field, how much seed is used, how much fertilizer is used. So I think tractors are, Milan level sexy, I think, very much.
All right, cool. Lots of data everywhere. How to make them business-oriented? We were talking about big data also before, but this is more focused. Yeah.
Right. I mean, I think that this is a huge challenge. People, data is critical, but more than data, people want answers. And I think that it takes domain knowledge, domain expertise, so knowing your business area to help people not focus on the data, but get to the answers.
Okay, got it. A quick recap in Italian.
Yeah, please.
Sometimes I really want to focus on it. Il punto secondo me importante
The most important point about Doug's presentation is the connectivity for all objects. Some years ago, we started talking about Internet of the Things, and people were saying, well, this is the usual buzzword and so on. But the truth is that all objects are now connected. Otherwise, you can't do the things such as the ones that Doug has showed us.
Could I just give a quick example on that?
Sure, please.
So one of the things people want to know when they look at a job site, there's 200 companies putting up a building. How far along is it? How am I on schedule? How am I on budget? And actually, there's approaches right now where people are using computer vision and computer models to answer that question, as opposed to working through a schedule and adding it all up. It's like, where am I right now, and how's my budget right now?
Can I ask you, Doug?
Yes.
Before this question.
Yes.
What's the most difficult project that you ever had tackle? Mines, skyscrapers. What is that?
I would say computer software is the most difficult challenge ever. But just an interesting
that never works.
Yeah. But in building construction today, around the world, we're not talking Italy, we're talking U.S. and around the world. About 40%, 40, is waste.
Okay.
40 is waste because of Someone's not ready to receive a part, the part doesn't come on time, designs change. This seems like a huge global opportunity to do better, save resource, get things done cheaper, faster. So I think as a society, turning these building projects into something that we can really deliver is a huge challenge.
Got it. Interesting. Which are the hardest problems to be solved in consumer vehicles autonomy? I take you there so that also people there can watch you. I don't give you my arm.
No, but but we'll go like this. Yeah. So I think that we were talking about this yesterday, and I won't say it's the hardest problem, but I will say it's a problem, which is what are the expectations of the people who are pedestrians surrounding these autonomous vehicles? I was in an autonomous vehicle, big California streets, big, busy streets. The vehicle is getting ready to make a right-hand turn. People are standing on the corner, clearly getting ready to walk across the street when the light turns green. The car, unfortunately, knows nothing about this. The light turns green. The car starts to turn into the people.
Right.
Still some improvements to make.
Okay, gosh. But do you think we're getting there anyway? But it's maybe more a collaboration than a total autonomous. I don't know if I would like... Can I ask the people, would you like a car that completely drives by itself? I mean, that you can't do anything, you can't even move a little bit, just let me do something, no? Is it true or not? Or is it only me? Yes or yes?
Yes.
Okay, cool.
But so I think the great debate, it's so fun that we're debating now, is this 5 years from now or 15 years from now?
Right.
We're not debating, will this happen?
Right.
It's definitely going to happen.
Okay. So, next question. HoloLens.
Yes.
Augmented reality devices and mobility. Which aspects of it... By the way, guys, it's the first time that I see the questions. I never read the question, just to let you know. Which aspects of experience are the strong and which the weak ones? Okay.
So we've actually worked closely with Microsoft on HoloLens. I will say it is an incredibly visually rich experience. And for me personally, it's one of the few things in the last 12 years, I'm not a millennial, you may be able to tell. One of the last things I've seen in the last 12 years is really just, wow, this is an all-new experience. So the visual experience is incredible, but I can't even use my thumbs to type. Okay. So it's just a very different mix of capabilities.
But how does it work? You have like some kind of glasses and you see in front of you holograms, basically.
It's basically seeing objects in the real world that I can walk around that object, I can see it from 3 dimensions, and it actually is quite stable and creates the illusion that that object is actually part of the reality I'm in.
How far we are from that kind of thing being reality, being in our hands? What do you think?
I mean, you ask Microsoft for a demo today. It's not actually a product.
I'll call Bill later.
But Google and others invested $500 million in a company last year to do this. Microsoft's doing it. Others are. This is a very near-term phenomena.
Cool. Let's see if we have a final question, maybe from our... Okay, I think probably we're done. Very good. So, Doug, it was really a pleasure.
Yeah,
Doug Brent, thank you so much.
Thank you.
Thank you so much.